Okay, now we're going to learn how to write or draw Lewis structures for molecular compounds. And as often the case when they give you a list of how to do something, it's more of a guideline than a hard and fast rule. There are other approaches, but this is the one we're going to use. So you want to start out with a good skeleton. It's almost Halloween. Let's talk about skeletons, right? So the skeleton is how the bones are connected, right? So here the skeleton is, well, how are the atoms connected to each other? We need to put them in the correct order. Then we need to figure out how many valence electrons do we have to work with in this molecule. We're going to look at the total number of valence electrons by looking at how many valence electrons does each of the atoms have. We'll add them up, and that's how many dots we can put in our structure. We're not going to be concerned about where the electrons came from. Up until now, I was drawing Lewis symbols for individual atoms, and then we were sharing electrons. That's one way to do it, but that's not the way the book does it, and so it's not the way I'm going to do it. We're going to make a skeleton, we're going to figure out how many dots, and then we're going to distribute those electrons and try to make as many people happy as possible. And so we're going to give octets or duets for hydrogen to as many atoms as possible. Sometimes there's not enough electrons. When you don't have enough of something, then you have to share, right? So if we don't have enough electrons, then we're going to do some extra sharing and make double or triple bonds. So those are the basic instructions. Let's do some examples. Write the Lewis structure for carbon monoxide. So the first step is to make the correct skeleton. Well, here we have two atoms, so we can't go wrong. They have to be next to each other, right? So there's carbon, here's oxygen. So how many valence electrons does this compound have? In total, it has 10. Carbon has 4, and oxygen has 6, and so that's a total of 10 valence electrons. So in order for this to be a molecule, there has to be a bond between those two atoms, right? It does look like love. I really did not plan that one. So, we've got to have at least a single bond for each atom so they stick together, right? So I'm going to put a single bond in there. Remember, that is 2 electrons. I'm going to draw a dot at each end just to kind of remind ourselves that's 2 electrons. We're going to do a lot of counting by 2. 2, 4, 6, 8, 10, right? So here's 10 electrons, so I've got 2 there, and I'm going to put 2 over 4, 6, 8, 10. Used up all my dots. Is everybody happy? No. If they were happy, we'd have 2 at the top, 2 at the bottom, 2 at the left, and 2 at the right. And so both carbon and oxygen are missing a pair of electrons. And so what that means is that we need to share more. So we're going to take some of these electrons that are lone pairs, they're not being shared at all, and we're going to cause them to be shared. So I'm going to move these guys. So I'm going to move that one. I'm going to move this one. And then that can be a bond. So that gives us more. Now carbon has 2, 4, 6, 7. And oxygen also has 7. But we're still not at 8. So we need to do more sharing. We still have some unpaired electrons, and so we can move those into sharing position. And share those. Now that looks like some weird sort of drawing, doesn't it? I probably wouldn't leave it like that because it looks weird. I've got carbon and a triple bond to oxygen. And then each of these guys has a lone pair. That's just a little more symmetrical. Looks nicer. Okay? Any questions? When we have the lines here, each line represents a covalent bond, which is a pair of electrons, 2 electrons. This is a triple bond because they are sharing a total of 6 electrons. Yeah, so my husband's Dr. K, I'm Mrs. K, and we have 6 children. So we have a triple bond. So 6 children. Write the Lewis structure for H2CO. Well, this one's a little more complicated because then we've got 4 atoms. The thing about hydrogen is it can only make a duet. It can only make one bond. So hydrogen will bond with one other atom. It cannot be in the middle of the atom. Of the molecule, we can't put hydrogen in the middle and have a bunch of stuff bonded to it. It's too small. So hydrogen's going to end up being on the ends. So let's try just putting one on each end, see what we get. So there's a hydrogen and a carbon and an oxygen and another hydrogen. And again, we need to count up the valence electrons. I have 2 hydrogens, they each have 1 valence electron. I have 4 valence electrons from carbon and 6 valence electrons from oxygen, so now I have 12 valence electrons. I'm going to put a single bond between each of these guys because they have to be connected. So now I'm going to start counting to 12. So I've got 2, 4, 6, 8, 10, 12. I'm done. Ran out of electrons, but oxygen isn't happy. Well, the hydrogens are happy because they only need 2. You know, hydrogen is weird. It has to break all these rules, and yet it's really easily satisfied here. Just give me one more electron, I'm good. Right? So hydrogen is real easy. But this oxygen doesn't have enough. So what do? We're going to share more. So right now, the carbon has 2, 4, 6, 8, and oxygen has 2, 4, 6. So the one that has 8, that's happy, is going to share some of what it has with the one who doesn't. You could get into all kinds of social things here. Oops. So I'm going to move a lone pair from carbon between these guys and make that another bond. Now this carbon has 2, 4, 6, 8, and oxygen has 2, 4, 6, 8. This is not the only way we could draw this. What if we put both of the hydrogens on the carbon? 2, 4, 6, 8, 10, 12. I still run out of electrons. So carbon has 8, so we're going to share some more here. And now oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. The hydrogens each have 2. It's all good. We will learn in a few minutes how to choose which of these is a better structure. Any questions? Pardon me?
You mean like choosing a central atom?
Yeah, basically. Choosing the skeleton, right? So here carbon and oxygen are both central atoms and hydrogens are the terminal atoms. Here we have carbon as a single central atom and oxygen and both hydrogens are terminal. Terminal just means it's only connected to one thing. If it's a central atom, then it's connected to two or more other atoms. We can also draw Lewis structures for polyatomic ions. The difference here is that we need to adjust the number of valence electrons, because if we have a negative charge on the ion, that means it's got some extra electrons. So we just add those in. And then we're going to put brackets around the Lewis structure and put the charge on the outside so it doesn't get tangled up with the dots. So let's do ClO minus. So that's chlorine and oxygen. And then we have to ask ourselves, well, how many valence electrons do we have to work with here? So chlorine has 7, right? Oxygen has 6. And the -1 means I add 1 or subtract 1? Add 1. Seems backwards, but so 12. Okay, so again, I need to have at least one bond between the chlorine and the oxygen. Yeah, 14. Just seeing if you're paying attention. It was creative math day. No, it isn't. It's mole day, actually. We'll talk about that later. Okay, thank you for catching that. So I've got 2 here. I'm going to go 4, 6, 8, 10, 12, 14. Ah, nice. I didn't have to do any extra sharing this time. The minus gets counted here, and now that I've done drawing that, then I put brackets around it and put the charge on the outside.
Yeah, that's what I meant.
Yeah. I just wasn't done yet. Any questions?